Joze emapletini bakho la kunandlela ongakho so into nje yakona yavela uyifile iba khona ebusuku 12 to 2 utshelo security
amile ngahlala eJozi hayi ungiphandele indawo la
mara it's expensive amaplate i-bedroom is 2000
right hayi right ngihlala nomuntu usebenza
ngishare
ngihlala nomuntu usebenza
umuntu beli kumbe beli
okay nje sishare
yeah exactly yeah once ukuthi uzobusekhaya ama
ngama
and if you are sharing the room it's share because nizokhipha 1.2 because ama bedroom abo 2.4
actually bachelor lapha ukukama
But I'm sure. Usebenza spare wena ungana fiber.
Spare vele ngabodade ngamanithi
yeah
color.
People who are just against you.
yeah there are TV la
Spare
Ngoba kuphethe 20 rand basebenzi. Do you need me here?
Boom, boom. Hello, grade 9 learners. Welcome to Department of Education. So today we are going to look at algebraic language. This is actually a revision session based on all the algebra you learned in the previous year. Okay. So the lesson objectives for today: by the end of this lesson, you should be able to recognize and identify conventions for writing algebraic expressions. This is where you should recognize the ghost one, where it would be as an exponent, or ghost one if it's a coefficient, such things. And also, you should be able to identify and classify like and unlike terms in algebraic expressions. We're also going to look at coefficients as well as exponents, and we will also be differentiating between the different types of expressions. your pre-knowledge from grade 7 and 8, your number patterns. You remember your input and your output, where your input is represented by an X and your output represented by a Y. And then exponents as well as algebraic language. All right, this is our baseline assessment. For these 4 questions, I'm going to give you 3 minutes to answer them, and then we'll do the corrections. Don't forget to send us your WhatsApp questions on 064 748 8913. 064 748 8913. So you can send me pictures of this baseline as soon as you are done. You have 3 minutes. All right, welcome back, class. Don't forget to send us your WhatsApps on 064 748 8913. Don't wait until the end of the lesson to ask a question. Do ask it as we go through the lesson so that you are able to keep up with all the concepts we are going to be discussing today. All right, so your baseline assessment is consider the expression 7x squared plus 9x minus 6. And then you have to first give a name to this expression. What do you call this expression? This expression is called a trinomial. Yes, because it has 3 terms. All right. And then the next part says list all the terms in this expression. You still remember what the rules are regarding your terms. The sign in front of the term is part of the term, and all your terms are separated by a plus or a minus. Multiplication and division do not separate terms, right? So that means you have 7x squared as your first term there. Then we have a plus sign, so that's a separation. That means the next term is 9x, and then we have a minus sign. That's also a form of separation. Therefore, we have 3 terms. 7x squared 9x, and the last term is not just 6, it's a negative 6. Remember, the sign in front of the term is part of the term, okay? And then C says, what is the highest exponent of this expression? So all you had to do here was to look at all the variables that have exponents and tell us what is the highest exponent. This is actually called a degree. We will be discussing this as we go through the lesson as well. All right, so the degree for this expression is 2. And then for D, which of the terms is the constant? Now remember, a constant would be a number that is not attached to any variables, right? And also in equations, a constant is actually a number that does not change, right? So here, what would be your constant? The constant is actually -6. If you said 6, please do correct that. It must be -6. So I'll just give you a quick minute for you to correct your work. All right. So for this question, for getting a trinomial correct, you get a mark. If one of your terms is wrong, you do not get a mark. But if all three are there, you get a mark. And then you get a mark for recognizing the highest exponent and also for having -6 as your constant. All right. So I'll give you 1 minute just to quickly fix your work. All right, class. So now we are going to get into the lesson. We are going to look at all the concepts that we will come across as we go through algebra in general. All right. So here we are looking at variables, coefficients, and constants. Right. So a variable is described as a letter or symbol representing the unknown. So by letter, we mean the letters of the alphabet, literally your A, B, C, Ds. All right, so it can be any letter that represents the unknown. It can represent a certain amount, a certain weight. Okay, and then you have a numerical coefficient, and this is the number that is in front of the variable, right? How is it attached to the variable? It is mostly attached to the variable through multiplication. All right, so here I just have one example for you to identify what the coefficient of x would be. Right, so you can raise your hand in class and answer this question. Okay, so the coefficient of x here is not just 2, but it's -2. Remember, you must be very careful with algebra to make sure that you still keep your integer rows in mind and your signs are part of your terms and also part of your coefficients, okay? And then we have a constant. We've discussed a constant already in our baseline assessment. This is a number without a variable, so it would be a number that is not attached to any other variables, right? And here it can be any number, -5, -10, 3, 7, 8, 100, 1,000, whichever number is not attached to a variable in the expression, okay? Don't forget, if you have questions, 064 748 8913. That is our WhatsApp line. All right, now let's look at an example where we actually need to understand the conventions that are associated with algebra, right? And how we write our coefficients, okay? Okay, so for this question, I actually would like to give you time to identify the coefficients for y, right? So I'm going to give you 2 minutes to identify the coefficients before we discuss them as a class. So you have 2 minutes. Welcome back, grade 9 learners. So I hope you got most of these correct. And if you're struggling, I hope you did ask for from assistance from your colleagues in class, right? You did get some help. Okay, so send me a picture of what you have as the solutions, as the coefficients of y for each of these expressions on 064 748 8913. Okay, so do send me those pictures. I want to see your work before we mark it so that I know if you understand it or if I need to go a little bit deeper into explaining it. Okay, all right, so we look at y, right? What would be the coefficient of y? Don't make the mistake of writing 0, okay? Because if you write 0, it actually means you do not have a term there, right? So your coefficient is actually a ghost 1, right? We do have a 1 in front of the y. It's attached to the y by multiplication, but we write it as a ghost 1. You remember Casper the Ghost? This is your Casper the Ghost in mathematics, okay? And then we have a negative y. What would be the coefficient? The coefficient here is actually a negative 1. So we don't show that there is a negative. We don't write negative 1y. We just show the sign and then we write the variable. So also there, the 1 becomes a ghost, okay? Or invisible if you're afraid of ghosts. So it's an invisible 1. And then for the next one, what would you say is the coefficient? Who wrote 3? Okay, so if you wrote 3, that was a slight mistake because you are missing something, okay? Your variable is y, and then right next to y in the numerator, you still have a coefficient, right? Which is a 1. So this fraction is actually 1 over 3, right? So the coefficient here is 1 over 3, okay? And for the next one, what is the coefficient? Let's check first. Raise your hand if you wrote that the coefficient is 4. Okay, so if you wrote that the coefficient is 4, you were almost there. You missed it slightly, all right? Because you needed to also include the denominator, which is 5. So actually, your coefficient was supposed to be 4 divided by 5. So it's 4 over 5, right? So what you need to recognize is that when you write your coefficient, you can actually separate your variable from the fraction. So let me just show you using these two. Okay, you see with this one, we have 1 over 3, which means we could have 1 over 3 times y. And here we have 4 over 5. It could be the same as 4 over 5 times y. Right, if we had to do the multiplication, we'd actually be able to come back to these two forms of fractions. You know, you multiply your numerators by the numerators. Okay, so I'm just giving you a second to just quickly correct your work if you have something wrong. So I'll stand here while you do that. Okay, don't forget, if you have questions, 064 748 8913. Do send us your pictures, send us your voice, send us your text. Don't send us voice notes, all right? I can't listen to them at the moment, but definitely pictures are welcome. We want to see your work, how colorful it is, how neat it is, and how quickly you are actually able to complete the exercises, all right? So I trust you all now have the corrections for this one, right? Okay, let's move on. So let's look at algebraic expressions, right? So we're just going to look at all the things that are associated with an algebraic expression. Number one is that an algebraic expression or an expression in general does not have an equal sign. So there's no equivalent, there's no sign that says this is equal to something else, right? Then it can describe a real life situation. So here it can be any situation, how many Cokes you bought minus how many, the amount you spent when you're buying chips and things like that. We will see some examples as we go through the lesson. The point is, with an algebraic expression, it can explain a situation, okay? And then also an algebraic expression is a representation of the operations that are done on numbers of variables in that expression. So what does this mean? This means that an algebraic expression, which is your x's and your y's put together, separated by subtraction signs and addition signs, actually tell you what you started with, what was done to that value, and also it gives you an idea of what the value could be. Okay. Right, so we have an example here. We have a situation. This example is actually explaining or describing a situation. What is the situation here? We have to divide a number by 2 and subtract 1, right? Okay, so we have a certain number that we have to divide by 2. And then once we've done that, what do we need to do? We have to subtract 1. Now, do we know what this number is? No. Therefore, it's an unknown number. As soon as you hear the word unknown, what comes to mind? A variable, right? So here you can choose any variable. Okay, so it can be any of the letters of the alphabet. And in my case, I'm mostly going to use X throughout our examples. You are welcome to choose any variables as we work through the situations, okay? So here you would divide X by 2 and then subtract 1. Subtract means you must use the symbol for minus, right? Okay. And then now I want you to describe a situation, all right? A situation that you can write algebraically, all right? So I want you to raise your hands in class and have a discussion about describing any situation that you can convert to an algebraic expression, okay? So I'm going to give you a quick 2 minutes to do that. Alrighty, I hope it was a very interesting discussion. I trust you guys are having a lot of fun as we go through this activity, okay? Now that you have an idea of what an algebraic expression entails, I think it's time we did some more. Right, so here's something for us to note. We use symbols to write words and numbers algebraically. We've discussed this, right? So here I want to explain exactly how do we recognize what sign to use or where the variable should be, okay? This is why I asked you to come up with some expressions or situations that you could describe algebraically, right? So now this is us actually checking if you got the concept correct. Right, so our example says a certain number decreased by 16, right? So we don't know what it's equal to, therefore it qualifies, this situation qualifies as an expression, okay? Now, a certain number, that phrase tells you that you have something that is unknown, therefore you need a variable, right? Remember I said I will be using X for my variables, all right? So we have X as a variable. It can be anything, P, Y, or Z, all right? And then the phrase decreased by, all right? This is when you need to recognize your mathematical language, okay? your product, your subtraction, coefficient, divisor, dividend. You need to recognize all of those words because you'll find that you will come across them, especially when you end up doing modeling with equations, okay? So here it says decrease by is represented by an operation. Now decrease by means that it gets less, so we use subtraction, okay? Right, and then we have this expression. Algebraically, it would mean that we would have a certain number represented by x, decreased by represented by a subtraction sign, 16 as our constant. All right, so it's x minus 16. Okay, you got it, right? So were you able to actually come up with algebraic expressions using the situations you described earlier? I hope you were. And if you did have a few good examples, please do send them through. Let's see what you're able to come up with, okay? All right. So now that you understand the concept of algebraic expressions, especially where we describe a situation, I think it's time for us to put that knowledge to test by doing these 3 questions. I'm going to give you just a very quick 2 minutes. They are very short. So I'll just give you 2 minutes to answer these questions. Don't forget to send us your WhatsApp 064 748 8913. So you have 2 minutes to answer the questions. Welcome back, class. So how was this activity for you? I trust you are actually getting this. Do you see how easy the subject can be? Right. All it requires is for you to apply just a little bit of thinking, right? So here, okay, my answers are all showing up, but let's just discuss them. First, a number that is 3 less than x. So this tells you that, okay, there's a certain value, right? And that value is less than 3. Is 3 less than x, which means x is actually bigger than that value. So you have to, if you had to write an expression for that, you'd actually have to subtract 3 from x, right? And then for the next one, the product of 2 and a number. So the word product implies that there's multiplication involved, which means you must multiply 2 with a certain number, right? So 2 times x, right? What is the product for 2 times x? It's 2x, okay? And then twice a number. So twice a number tells you must multiply that number by 2. So it's 2 times x again, and this time you still get 2x. All right, so for each of these, if you have them correct, you'll get a mark. All right, if you do happen to have a test where you are asked to do such an example where you have to write an algebraic expression, you'll find that you'll get more marks because, for an example with a, you'd actually get a mark for recognizing the correct position for the variable and also for using the correct operation, right? So you'd find that you get 2 marks for such an expression as in A, okay? All right, so take a picture of your work once you've marked and let's send it to 064 748 8913. Okay, let me just give you quick time to copy this. I'll give you 1 minute just to correct your work before we move on. All right. Welcome back, class. So now let's continue and look at terms. Remember, we are just going through all the concepts that are associated with the algebraic language, right? So we are going to look at terms. I know you know something about terms. We have like and unlike terms. Everybody knows that, right? So what do we need to know about terms? Is that they are separated by an addition sign or a subtraction sign. And don't forget, we've mentioned this before, the sign in front of the term is part of the term. And also, a term in an algebraic expression can be a single number, which means a constant is actually a term on its own, or it can be a combination of numbers. Here we are talking about if we had 2xy, that would be a complete term, or even 2x, that's a complete term where you have a combination of numbers and variables that have been multiplied together. Remember, in algebra, we don't actually generally show all the multiplication signs unless if it actually impacts the operation, right? So you know that variables and constants or coefficients, those are actually in between them. There's a multiplication sign, but we don't usually write it, right? Okay. And also, very important for you to note this one. A bracket is actually considered as one term, all right? So a bracket, it doesn't matter how much is inside the bracket, it will be considered as one term. Right, so here we have an example. It says how many terms are in the expression. So raise your hand in class while I'm on screen and actually answer this question. How many terms are in the expression? Okay, now that you know how many terms are in the expression, what are the terms? What's the first term? And the second term? Do you also have the third term? Okay, let's see if you are correct. So here we have 3 terms, right? The first term is 2a. Do you see that? So 2a is positive, we just write it as 2a. The next term that we have is, yes, you've got it, negative 3c, right? It's negative 3c. This is when the part about the sign in front is part of the term. Okay, especially when it's negative. All right, and then the last term is a constant. It's positive 4. Here you don't have to show the positive sign, so you can just write it as 4. Okay, right, so this is basically what we need to note about terms. We are going to move on now. Right, let's see if you were able to note the important part about terms. So I want you to answer these questions. How many terms are in the following expressions? And you should also just give me an example. All right, you can write this in your book or even just raise your hand in class and discuss it in class. All right, so I'll give you just 1 minute to do this. All right. Do you have the solutions to these two questions? Okay. So here we have 2 times x plus 3. So the x plus 3 is in a bracket minus 3y. I'm mentioning the bracket so that some bells should come into your mind, right? Do you still remember? How many terms do we have? I know you see a plus and a minus and immediately you say 2. That is not correct, okay? You need to look at where the positive sign is or the addition sign is and where the subtraction sign is, right? So the addition sign that is inside the bracket, the terms, even though the bracket itself has 2 terms, but the whole bracket is considered as a term on its own. Therefore, with that, it means that we only have 2 terms. And those terms are actually 2 times x plus 3 is 1 term and negative 3y. You remember your bracket actually represents multiplication. That's why when I say it, I say 2 times x plus 3 because your bracket in algebra can sometimes indicate multiplication. So that is also another very important convention for you to note. All right. Okay, so here we have 2 terms. Why? Because a bracket is regarded as only 1 term. And then for B, we have 2x over 3. All right. Now here we actually only have 1 term. All right. And this is because the division line is actually just treated like a bracket. Okay. So with your fractions, we treat our fractions as 1 term. Okay. Very important for you to note is that your simple fractions are treated as a like term. Okay. As 1 term. Sorry. Right, so if you have questions, please do send them on 064-748-8913. Also, if you'd like for us to see your work or if you have input about today's lesson, do send it on 064-748-8913. Okay, now let's look at factors. Remember, factors actually make up your terms, right? So it's the components that make up the terms, right? So factors are joined by multiplication. I did say that even though the multiplication sign is not always written, we just know that it's there. So here's an example. How many factors are in the expression? 3a. And then we have a bracket 2 plus a, right? I'm not using the correct term here because I don't want to give you hints. So I want you to tell me how many factors are in the expression. You can just raise your hand in class or even send us a WhatsApp on 064-748-8913. How many terms are in the expression? Did you get it correct? I think you did. So here we actually have 3 factors. Sorry, not terms. We have 3 factors. Okay, 1 term, 3 factors. Okay, the factors here are 3. Okay, because we have 3 being multiplied by a, and also it's being multiplied by 2 plus a. 2 plus a is considered as 1 factor because it's inside a bracket. Okay, so 3 times a times 2 plus a. Therefore, we have 3 factors, right? So, summary, we have 3 factors in this expression and how many terms? 1 term, right? Okay. Now, let's look at like and unlike terms. Like terms, these are terms that have the same variables, and those variables will usually have the same exponent, right? Now, with like terms, we can multiply them, right? So we have an example here where we are multiplying 2x times 3x. When we are multiplying like terms, we need to keep in mind our exponential laws. There is a lesson coming up on how we do that. But for example, here we are multiplying powers with the same base because powers that have the same base, x and x, do you see that? So we just add the exponent. Remember here, we did discuss our conventions. We don't write 1 as a exponent, right? So we're actually just adding 1 plus 1 to get x squared, and then we multiply the coefficients, 2 times 3, and that gives us 6. Okay, and then with like terms as well, we can add them. Don't make the mistake of changing the exponent, right? When we are adding like terms, the exponent remains the same as the one that was in the expression to start with. So x was raised to the power of 1. Therefore, even in your sum, you'll still have x to the power of 1. All right, so 3x plus 2x. We just add the coefficient 3 plus 2, and that gives us 5x. Right. And for the next one, we have subtraction. So this tells us we can subtract like terms, right? So which means we can simplify like terms through subtraction. Okay, so what do we do there? We just have to work with the coefficients. We leave the base, right? We leave the variable x, right? We don't change the exponent. Don't make the mistake of now thinking you have to apply different exponential law. You don't change the exponent. If the variable was just x, you write it in your answer as x. And what you do is you just subtract the coefficient. You say 3 minus 2. It will give you a 1, right? But because with our algebraic conventions, we do not show the 1, it becomes invisible, then your term is just x in the final answer. All right. Right, now let's look at unlike terms. So with unlike terms, these are algebraic terms that do not have the same variables or coefficients and cannot be raised to the same power. What do we mean by this? We mean that you'll find that yes, they have coefficients, but the variables, they are x and x, but then one of them is x squared and the other one is x cubed. Those are not like terms. Do you see that? Because we said like terms will have the same variables raised to the same exponent, right? So what can we do with unlike terms? We can multiply unlike terms to get one term. All right, so we can multiply them. For example, here we are still using the same values, 2x times 2y. So here we can tell that these are unlike terms because one has an x as a variable and the other one has a y as a variable, right? So we just multiply 3 times 2, we get 6. So we multiply the coefficients and then we write the variables again, x, y. Right. Can we add them? No, we cannot add them. All right. I know you've had that saying where your teachers say, when you are told you cannot add apples and oranges, x and y, we do not add those. All right. And also we cannot subtract them as well. Right. So we cannot simplify unlike terms if the variables are different or if the variables have different exponents. Okay. Just keep that in mind. So in summary, this is very important. We can only add or subtract like terms and not unlike terms. Okay, so just keep that in mind because you will find that you'll be asked to simplify expressions in our next coming lesson. And you need to recognize your like terms and your unlike terms before you even start the whole simplification process. Right, now let's look at types of expressions. So we've done a part where we actually created our own expressions. We've done a part where we were given expressions and we had to write them down out mathematically. Now let's look at the types of expressions that we have. All right, we have a monomial. That's one of the common ones that we use, and a monomial is made up of one term. All right, so an example can be 2x 3y negative 5x. All right, so basically you'll just have your coefficient, a few variables, no other addition or subtraction, nothing added to that term, right? Then binomial, when you think of binomial, you are thinking of a bicycle that has how many wheels? 2. So that tells you how many terms do we have? We have 2 terms. Right, so here we have an example, negative 5x and negative 5x minus 3b. All right, so remember the sign in front of the term is part of the term. So there, that's one term. And then this one, negative 3b is your second term. Right, do you have another example for a binomial? Just raise your hand quickly. Well done if you got an example. Right, now let's look at the third one. It's a trinomial. So when you think about a trinomial, you think about a tricycle. It will have how many wheels? 3 wheels, right? So a trinomial has 3 terms. It's made out of 3 terms. Okay, so here we have an example of a very common trinomial, x squared minus 3x plus 2. Right, so trinomial of 3 terms. We have x squared as our first term, minus 3x as our second term, and 2 as our third term. Right, a trinomial, you also just need to keep in mind that a trinomial is actually a type of polynomial That is an example of an algebraic expressions with many terms, okay? So let's look at polynomials. Right, the polynomials are made up of many terms, all right? So the degree of a polynomial is given by the highest power of the variable. So here we are looking at the exponent, right? The highest exponent in the expression tells you the degree of a polynomial. I did give you a question in the baseline that asked you what is the highest exponent, and that was actually asking you what is the degree of the expression, right? And you actually got that correct. So it means you know this stuff, right? Okay. Don't forget to send us your questions on 0647488913. We are nearing our WhatsApp interaction session. Please do send us your questions or pictures of your work as we go through this lesson. All right. So now let's look here. X is raised to the power of 1. Therefore, the degree for this expression is just 1, right? And then in this case, the highest exponent that we see is 2 for the variables. Therefore, the degree would be 2. Do you see that? And then an expression raised to the third degree would mean that the highest exponent for the variables in that expression would be 3. All right. Right. Now, also something to note with polynomials and expressions is that we write them in descending order of powers. So what this means that we'll always write the term that has a variable with the highest exponent first and keep going until we get to the term that actually does not have any variables. Right, so here we have an example with 2y to the 4 minus 3y cubed plus 2y squared minus y to the 1 plus 12. All right, what can we change about this expression? Right, we don't really need to show the 1 as an exponent. We just have to know that it's there, right? So we could just rewrite it like that. And then if you notice here, we started off with the highest exponent for y, which is 4. Then it goes 4, 3, 2, 1. With the 12, do you know that we actually do have a y there, right? The only thing is that it's raised to the power of 0. Do you still remember exponential laws? Anything raised to the power of 0 is equal to 1. So we're actually multiplying 12 by 1. That's why we just have 12. But if you were to write it down, you could say 12 times y to the 0, right? Now we have an activity, okay? So for this activity, we have 6 questions. I'm going to ask you to do the first 3 questions first. And then after you've answered those, we'll continue with the next. I don't want you to maybe end up making too many mistakes. I want you to be in touch and keep on track with the activity and also be able to correct your work as we go through the lesson. So for these 3 questions, I'm going to give you 3 minutes to answer them before we do the corrections. So you have 3 minutes for these questions. All right, class. So here you were asked to look at the expression, right? And then answer the question based on the expression, right? So the first question says write the expression in descending powers. So what you had to do here was to take the term that has a variable with the highest exponent and write it first, right? The trick here would have been for you to recognize that when you move terms around, you must move them around with their signs, because we said the sign that comes before the term is part of the term, right? So we recognize that the first term that we have to write down is is the one that contains x to the 5. So when you write it, don't just write 3 times x to the 5, but make sure you write it as negative 3x to the 5. Okay. And also, when you move the 15 there to the last part, don't just write plus 15. Make sure you take it along with the negative sign, and it becomes minus 15 in the expression. All right. So for this question, I think for every expression, let's go. So 1, 2, you get 3 marks for this question. Right. For every 2 terms that you put in the correct place, you get a mark. All right. Very generous, right? Right. The next one says, how many terms are there? You just had to count. Right. Let's just use this expression. We have 1, 2, 3, 4, 5, 6 terms, right? So that would have been your first answer, the 6 terms. And just for doing that, you get a mark, right? And then the next part would have been for you to list the terms. So when you list the terms, very important to remember what? That you must write the term down with its sign, especially if the sign is negative. So the first term is negative 3 times x to the 5, and then you have 2 times x to the 4, and so forth, right? And your final term would be negative 15. Now here, the order was not important. As long as you have all the terms, you get a mark. Just make sure, double check that you've written down all the terms, and each of the terms has the correct sign. All right, are you looking? Okay. So far, how are you doing? I'm going to clear up our screen so that you are able to copy the corrections as we go through the lesson. Remember, I said you are getting 3 marks. So you get a mark for 2 and 2 and 2 of those. You get a mark there and 1 mark there. Right. So you've corrected that, right? And then for the next part, what type of expression is shown above? Right. So now, remember we said that we have a monomial, a binomial, a trinomial. We also have more which are called polynomial, and we said trinomials are part of that as well, right? So what type of expression do we actually have here? If you gave the very specific name, that's also okay, but also if you just wrote a polynomial, that is very good as well, right? I know some of you might know what this expression is called in terms of the counting numbers that we use, right? But for today, I just need you to write it as a polynomial. All right. Then for recognizing that, you get a mark. Right. So everybody has corrected their work. I'm going to give you just 1 minute to quickly correct your work and make sure you have all of these correct, because we don't want this affecting the next questions that you have to answer. So you have 1 minute. Okay, class. So let's move on to the next three questions. What is the degree of the expression? What is the constant term? And what is the coefficient of x to the 5? So for this question, because I just need you to write quick numbers, I'm only going to give you 2 minutes to answer the question. So you have 2 minutes to answer these three questions. Okay, class. So I do have a question from Palm Ridge Secondary School. I will answer it as we go through the lesson. Right, so Palm Ridge Secondary School, noted, okay? Right, so now let's look at this question. What is the degree of the expression? So that is simply asking you what is the highest exponent in the expression. And the highest exponent we have for a variable is 5. So the degree is 5, okay? And what is the constant term? The constant term is a negative 15. Very important, don't write 15. If you wrote 15, it's not correct. You must write the sign in front of the term. Right, so it's negative 15. Then what is the coefficient of x to the 5? So here you go to your expression and you look, where's x raised to the power 5? Right, what is in front of it? A 3. And what is the 3? What is in front of the 3? It's a negative. So you actually have to write that complete section as a term. Okay, so it's actually negative 3. All right, so for this you get a mark for having a 5, a negative 15, and a negative 3. You can quickly correct your work while I'm on screen. Okay, so you haven't sent me any pictures. Do send me your work. Let me see how much you got. What is your total? So write your total for me after you've marked and send it on 064 748 8913. Let's see how you are doing, okay? Right, I trust you all have the correction. So your answers are 5, negative 15, and negative 3. Right, you've got those. Right, let's move on. So with the homework, I'm going to ask you to please just quickly take a picture, all right? But I'll give you just a quick 2 minutes if you can write that quickly, but just take a picture fast so you have 2 minutes for this. All right, guys. So I hope you've taken a picture. You just had to quickly snap. And if you're not done, do copy from somebody who is done, okay? All right. Now, let's look at the question from primary secondary school. So what they had asked actually is a question about a session we are still going to have, which is simplifying algebraic terms. So for today, I just wanted you to recognize the like terms and unlike terms. I didn't really need you to simplify, but the question was, how do we do calculations where you are given 3x minus x? Okay, that's an x, all right? All right, so here what you're looking for is to recognize first that the 3x minus this, there's actually a ghost 1 there, right? That's the first thing you need to recognize. And then from there, all you have to do is to actually just take the coefficients and subtract them. So 3 minus 1, and then this will give you a 2, right? Because these two are actually like terms. You still remember we've discussed like terms, and we did say we can add or subtract them. Now, because you have like terms here, you get a 2. So that means the answer to this question is actually 2x. You don't change the x. You don't change the exponent for x. It just stays the same. So you return the x as it is. But should it happen where you get a question where you get 0x, the answer is just 0. Remember here, it's 2 times x. So 0x would be 0 times x. And anything multiplied by 0 will give you a 0. All right. I hope primary secondary school, you are answered for this question. Now, let's look at our summary. Right, the 3 main parts of an algebraic expression, we've discussed them, right? We had a variable, and then we also had a coefficient, and we've also seen a constant. Those parts are what usually make up our algebraic expressions, right? And then like terms, remember like terms will contain the same letters of the alphabet and the same exponent. So those letters will be raised to the same exponent. By letters we mean variables, right? Then you also your unlike terms, right? Unlike terms will have different variables, and most of the time if the variables are the same, they will be raised to different exponents. Remember, for us to say it's a like term, the variables must be the same and they must also have the same exponents. Okay, right, so in the next lesson we are going to be looking at expanding and simplifying algebraic expressions. This part is for you who was asking about simplifying algebraic expressions today. Okay, thank you so much for joining us today. This lesson is proudly brought to you by the Gauteng Department of Education. Please remember to sanitize and wear your mask, and also keep social distancing. All right, we want our families to stay safe. I will see you in the next lesson.